All right, today we are diving headfirst into a real cosmic detective story. We're following the trail of this one super peculiar object out in deep space. And let me tell you, its story has been a roller coaster, complete with a massive plot twist.
So, our whole story really hinges on this one central mystery. How in the universe can a single collapsed star seem to have two totally different personalities? That question, right there, is the key to cracking the strange case of Pulsar B2020+28.
So, before we can get into all the weirdness surrounding our subject, B2020+28, we've got to start with the basics. What even is a pulsar? Okay, so picture this. A massive star goes supernova, and what's left behind is this incredibly dense, spinning core. That's a neutron star. Now, these things shoot out powerful beams of radiation from their poles. As the star spins, these beams sweep across space, and if one of those beams happens to sweep past Earth, we see a regular pulse of energy. The best way to think about it is like a cosmic lighthouse, just rhythmically flashing out there in the dark. The specific lighthouse we're zeroing in on today is known as Pulsar B2020+28. It's actually a pretty strong pulsar, which makes it a fantastic subject for scientists to study. You can find it out in the constellation Vulpecula, which is Latin for the little fox. Now, this is where it gets really important. Let's talk distance. The latest, most precise measurements we have put this pulsar at 1.39 kiloparsecs away. A kiloparsec, if you're wondering, is just a huge unit of distance astronomers use. In this case, it translates to about 4,500 light-years from us. This number is the crucial piece of evidence in our whole story, so do me a favor and keep it in the back of your mind.
But here's the thing. B2020+28 isn't your average, run-of-the-mill pulsar. Not at all. As a 2012 study showed, it has this strange quirk. Scientists call it mode switching, but honestly, you could almost think of it like it has a split personality.
So the pulsar just abruptly switches between two very distinct states. Most of the time, it's in its normal mode, where the pulse intensity is a little bit wobbly and unstable. But then, out of nowhere, it'll flip into this abnormal mode, where the pulse is much more stable, and its overall brightness actually jumps up by a factor of 1.3.
And if you look at how it splits its time, it's pretty lopsided. It hangs out in that normal, less stable state for almost 90% of the time, and only spends about 11% in its brighter, more abnormal mood. This bizarre behavior is what first put this pulsar on the map and made scientists want to dig a whole lot deeper.
So this weird mode switching, this cosmic moodiness, it really got a lot of attention. And it led scientists to a fascinating, and I mean really dramatic theory about where this thing came from. The big question became, could it have a long-lost twin?
Then, in 2004, a team led by Wouter Vlemmings published a paper with this absolute blockbuster of a title. They proposed that our pulsar B2020+28 and another one nearby, B2021+51, were basically cosmic siblings, born together and then violently thrown apart. The theory was just so elegant. It suggested that two huge stars once orbited each other. When one went supernova, boom, you get the first pulsar. Then, a bit later, the second star also went supernova, creating the second pulsar but also violently kicking both of them out of the system, sending them flying through space in opposite directions. And the craziest part? When they trace their paths backward, they seem to meet at the exact same spot. And here's the absolutely critical thing to remember. This entire compelling theory was built on the best data they had at the time. And those measurements put our pulsar, B2020+28, at a distance of 2.7 kiloparsecs and its supposed twin at 2.0.
For more than a decade, that separated at birth story was the leading explanation. It was a great story. But in science, as you know, a good story is only as strong as its evidence. And it wasn't long before new technology allowed for a much, much closer look. And this became the central question, the one that could bring the whole beautiful theory crashing down. What if the very foundation of the idea, those initial distance estimates, what if they just weren't right? So, in comes a new team of cosmic detectives, led by Franz Kirsten, who decided it was time to reopen the case. They used the incredibly precise European VLBI network, which is basically a network of radio telescopes all over the globe working together to measure the pulsar's positions and distances with an accuracy that was just impossible before. And what they found was, well, it was stunning. It was a total game changer.
The new data completely rewrote the map. B2020+28 wasn't 2.7 kiloparsecs away, it was at 1.39. Hey, remember that number from the beginning? And B2021+51 was at 1.25, not 2.0. Both of them were way, way closer than anyone had realized.
I mean, this chart really puts it into perspective, doesn't it? The measured distance to our main pulsar, B2020+28, was nearly cut in half. A correction this massive doesn't just tweak a theory, it can blow it right out of the water. So, with this new, much more precise evidence on the table, the team could finally close the book on the separated at birth hypothesis for good.
Yep, the verdict was crystal clear. With the corrected distances, the trajectories of the two pulsars no longer trace back to a common origin, not even close. That beautiful, dramatic story of cosmic twins was officially disproven by better data.
So what's the big takeaway here? It's not that the first theory was bad science, not at all. It was the absolute best explanation based on the evidence they had. This is just a perfect example of science's self-correcting process in action. As our tools get better, our understanding gets sharper. We now know these pulsars are not twins, which means the true origin of B2020+28 and its strange split personality is an open case all over again.
This whole case just goes to show you that for every answer we think we found in the cosmos, a bunch of new questions pop up. It reminds us that the universe is just filled with these incredible stories, and with every new measurement we take, we get a chance to read a brand new page. Makes you wonder, doesn't it? What else is out there?